Hello, I'm Dr. Sri Banerjee, and in this segment, what I'll be going over is how to conduct a meta-analysis. Now, when you're thinking about a meta-analysis, typically you have a systematic review before you conduct a meta-analysis. I have several papers out there that I had to conduct meta-analyses on. So I will be using my experience and the literature to present to you what meta-analysis entails. So let's go ahead and get started. Overview, background and context, applicability in the real world, step-by-step process, conclusions, and then questions. So assessment of the study quality. Assessing quality, there's multiple scales. There's the Strobe scale, and I'm not going to go over the details of these. Good to know these acronyms, though. You also have the Newcastle Ottawa scale, and then the NTP Office of Health Assessment, and then the Critical Appraisal Skills CASP. I've used this one before, and Strobe. So in this slide, this is extracted from Lam et al. 2020, and this is something that they were talking about within the paper. Systematic reviews were identified from a broad range of databases, PubMed, Embase, and Web of Science. These were screened to identify studies that were a systematic review and investigated chemical components of traffic-related air pollution exposures, otherwise known as TRAP. They also reported on any health-related outcome. So these studies needed three things. It needed to be a systematic review, it needed to look at TRAP pollutants, and then it needed to have a health outcome. So after the search of the scientific literature, they found 58 systematic reviews relevant to TRAP exposures in human health conditions. Systematic reviews were published between 2010 and 2019, but not all were identified as such by the study authors. The majority of the studies were identified as being a systematic review by the study authors, of which 27 also included a meta-analysis for quantitative synthesis of data. One study identified as only a meta-analysis without reporting that it was a systematic review. Another study identified as a catalog and synthesis. So there's different types of studies that were there. So in total, 27 of them included meta-analysis. So in this current slide, I've put a actual meta-analysis forest plot. This is a forest plot that I created from some of the studies about. This is actually in Nigeria, so the number of studies were limited. 8 different studies were looked at, and then conclusions were made from that. So one thing to keep in mind when you're thinking about the importance of meta-analyses is that not all narrative reviews end up in meta-analysis. There may be many narrative reviews, but not all of them conduct meta-analyses. The rest of this slide you can go over on your own. So going over to the next slide. So thinking about the background and context, the definition of meta-analysis is to seek and integrate communications and conclusions across multiple studies and disciplines by applying statistical analyses to groups of studies. In terms of meta-analysis, why is it important? Researchers can estimate not only the central tendency of study outcomes, test the pattern of outcome variations, and estimate the overall effects and relationships of variables, but also predict results of future trends. So here is an actual funnel plot that I created when we were conducting research on psychosocial stress in occupations such as guest workers. And this was actually conducted in Nigeria, so we didn't find too many studies that included some of these variables. So here each dot, and I don't know if you'll be able to see this, each dot represents a single study. Larger studies with higher power, they're more at the top. X-axis shows the result for the study, sometimes expressed as an odds ratio. So this is quite well distributed. Not all the dots are in one place, which is always a good sign. So let's take a look if that's the case. So here's a slide on effect size. And this is a measure that is important in a lot of statistical tests. And it shows the contribution of each of the variables into in the data set. So looking at this, the absolute effect size computed as a mean outcome or absolute difference from baseline is the simplest, is independent of variance and retains information about the context of the data. So the absolute effect size requires authors to report on a common skill or provide conversion parameters. Standardized mean differences such as Hedges G or Cohen D report the outcome as the size of the effect. Standardized mean difference is widely used in meta-analysis, in addition to odds and risk ratio. Now let's take a look at why funnel plots may be imbalanced, and not everything will be as you expect. One of them is poor methodological design, including fraud or inadequate analysis. Reporting bias, including delayed publication location bias, selective outcome reporting, and selective analysis reporting. Chance, 95% of studies will usually fall within the triangular region if there are no biases or heterogeneity present in the studies. One possibility to skew the shape is that the errant 5% might all fall in one particular area by chance alone. The 95% rule is actually a probability, meaning that chance alone could cause a higher or lower percentage than 95%, causing an asymmetrical shape. Study heterogeneity. If heterogeneity results in a correlation between study intervention effects, this will result in an asymmetrical funnel plot. So fortunately, in the study that I actually participated in, I actually conducted the analysis. Fortunately, the funnel plot was pretty balanced. So here's Cochrane's Q. Simple way to assess heterogeneity, variations in study outcomes between studies. In meta-analysis it is important to perform Cochrane's Q test. Q test is based on the estimation of a weighted average of effect in the overall population. The evaluation of whether stratum-specific effects significantly depart from the common effect. So here's Q, and that was the value for Q right here. And then significance level was actually statistically significant. So there was heterogeneity in the studies that were conducted, and not all studies were all concentrated into one area or the other. So these are some examples. This is an example of the TRAP systematic review by Lam et al. There's more information, and then there's studies which have been categorized by the different cardiorespiratory conditions. So like lung cancer, there's 3 articles. Cardiorespiratory disease, 1 article. Cardiovascular disease or effects, 5 articles. Lung function, 1 article. So this is a good example. And then, of course, health outcomes. There's some more here. For instance, diabetes risk, childhood cancer, cognition, congestive heart disease or abnormalities. What are the advantages? Use explicitly and predefined methods to limit bias. Use transparent and replicable methods that allow reproducibility. Draw more reliable and accurate conclusions based on the overall body of evidence. Deliver required information to healthcare providers, researchers, and policymakers. One of the things I wanted to note here is that typically systematic reviews and meta-analyses are actually seen as more evidence-based than observational studies. So the level of evidence is much higher. And then help to reduce the time delay for research discoveries and improve the generalizability and consistency in results. And then finally, increase precision of the results and highlight research and knowledge gaps. So caveats to consider, I'm not going to go over all of these. The value of systematic review or meta-analysis depends on what was done already, and this is inherently obvious. Reporting quality varies, limiting ability to assess strengths and weaknesses. Inherent flaws include heterogeneity, loss of information on important outcomes, and whatnot, and then publication bias. So this is an overview, again, as to how you go into the background and context and availability of the real world, availability in the real world, and then step-by-step process, and then conclusions, and then questions. So this is the systematic review versus meta-analysis. And there's some examples of bisphenol A. So there's actually two models used in meta-analysis, fixed effects and random effects. So the fixed effects model assumes that the true effect of treatment is the same for every study. Of course, the methods section should include description of the literature search, especially the databases used, and if the search was restricted in any way. The selection process for articles, quality assessment methods of data abstraction and synthesis. So those are those CASPA and STROBE acronyms that you can use to make sure that you're using the proper techniques. The results section, of course, include a flowchart and a forest plot, resulting of heterogeneity testing, and also results of a sensitivity analysis. Again, I went over a forest plot already. When you conduct a meta-analysis, meta-analysis is applicable to collections of research that are empirical rather than theoretical, examine the same constructs and relationships, are comparable given the question at hand. So what is the key in the process? The effect size makes a meta-analysis possible. It is the dependent variable. It standardizes findings across studies such that they can be directly compared. And then the standardized index, which is an effect size, comparable across studies, represents both magnitude and direction, is independent of sample size. So the meta-analysis on psychosocial stress. So here is how to do a research topic, and I've put a lot of flowcharts in here, so you can go over this on your own. Step one, and I'm going to go into this a bit more detail. Step one is formulate the research question or topic. So formulating the question to be answered or selected topic. The statement of the topic will guide study selection, coding of information, and data analysis. There's a set of examples that you can look at. So the example of my research, I actually did not even give you the topic or the title. Before that, I was presenting the funnel plots and the findings of the study. So we did this backwards. but the name of the article was "How Prevalent Was Psychosocial Stress Among Gas Workers in Nigeria?" So set inclusion and exclusion criteria, language, sample size, types of publication, study design, data collection. Select effect size and precision. Select a comparable effect size measure for each evaluation study, including its variance. Standardized mean difference, D and G, from independent and dependent groups. And then the raw mean difference. Conclusion, weakness of meta-analysis. Well, selection bias poses a continuous threat. Negative and null finding studies that you were unable to find, and outcomes for which there were negative or null findings that were not reported. So analysis of between study differences is fundamentally correlational. Another conclusion, weakness of meta-analysis, easier with current software, requires a good deal of effort. Mechanical aspects don't lend themselves to capturing more qualitative distinction between studies. There's the apples and oranges criticism, where you're sometimes having to synthesize multiple articles which are not quite similar. And then most meta-analyses include blemish studies to one degree or another, a randomized trial with too much attrition. I hope this has given you a sense of what meta-analyses entail. Thank you for listening.